Okay, in this concept, we're going to talk about measuring angles in radians. Okay, now a radian is essentially another unit that is used to measure angles. Okay, we've been measuring angles in degrees thus far. Now we're introducing this new unit called a radian. So a radian is the measure of an angle which, if the vertex of which is placed at the center of a circle, the angle intercepts an arc equal in length to the radius of the circle. So if we put the center of the vertex of this angle at the center of a circle, and we measure 1 radian of angle, okay, the angle intercepts an arc equal in length to the radius. So if this circle has radius, 1 unit of 1, right? Then the length of this arc is 1. So the length of the arc is the same as the length of the radius. Okay, r and r. 1, 1, 2, 2, etc. Okay, so the whole point is for the length of the arc to equal the length of the radius. Now in the figure above of the length of arc, again, we've been discussing this, so the length of arc AC equals the radius r, then angle AOC, this angle with this vertex, right, this angle, is an angle of 1 radian. This is the definition of radian. Now it may seem arbitrary, it may seem just, not straightforward, but it'll have its uses, and you'll be clear on why we introduced this unit of measure. Okay, it does have its applications. Since the circumference of the circle is 2 pi r, right? We know this from before. The radius can rotate around the circle exactly 2 pi, or about 6.28 times. Okay, meaning if you want to take this radius and make the circle of putting this radius back to back, putting the length of the radius back to back, as an arc multiple times, it would take you 6.28 times the radius, times the value of the radius, to get the circle. Okay, so I have this circle, for example, of radius, 3, right? 3 whatever, centimeters, inches, whatever. So it would take me this value 3 times 6.8 times, like that. But of course it would be curved, right? Like it wouldn't be straight, to curve, but to take the same distance, right? To make up the circumference of the circle. That's why the radius is 2 pi r. So obviously 2 pi is the 6.8, right? Or I'm sorry, 6.28, because pi is obviously 3.14, right? So 2 pi is 6.8. So this part is 6.8 multiplied by the value of the radius, okay? That's what circumference is. So in other words, 2 pi is a complete rotation of 360 degrees. We know this. Now, since 2 pi is 360 degrees, then pi radians is 180 degrees. Okay, so pi radians is 180 degrees. Or 3.14 radians, right, which is the value of pi, is 180 degrees. Okay? Now 3.14 degrees is just, 3.14 degrees, right? As opposed to 180 for 3.14 radians. So that's why you should always be sure of the unit of angle measurement that you're using, okay? Because it obviously does affect the results. Radian and degree measure. To convert or to rewrite the radian measure of an angle in degrees, basically converting between radians and degrees and vice versa, multiply the number of radians by 180 degrees over pi, right? So why is that? So we just said that pi radians is 180 degrees. So 180 degrees over pi radians is 1, right? It's the same, these two have the same value. Okay, so if we have radians, if we have an angle in radians, again, so pi radians, for example, right, radians, pi radians times 1 is just pi radians, but then I want to make this 1, you know, I want to put this in place of the 1, right? So pi times 180 degrees over pi, this is 0, right, is equal to pi cancels with pi, and then we just get 180 degrees, right? To rewrite the degree measure of an angle in radians, multiply the number of degrees by pi over 180. So keep the degrees down so you can cancel. So again, let's say we have 180 degrees, an angle of 180 degrees, times 1 is just 180 degrees, but again, I'm going to rewrite the 1 as the inverse of this, and it's still 1, right, because these two are the same thing. Again, pi radians is equal to 180 degrees. So 180 degrees times, now I want to get the radians, and I want to cancel the degrees, so I'm going to put these down here, the 180 degrees down here, so that these two cancel out, and I end up with pi radians. Okay? So 180 degrees is equal to pi radians. Let's look at some additional examples. Express 130 degrees in radian measure. So again, we have degrees, we want to convert to radians. So then we multiply by pi over 180, right? Because we want to cancel out the degrees and leave the radians. So 130 divided by 180, cancel the zeros, is simply 13 over 8 pi radians, right? 13 and 18, I'm sorry, 13 over 18. I said 13 over 8. 13 over 18 cannot be simplified any further, so this is the result, right? So 130 degrees is 13 over 18 pi, or 13 pi over 18, same thing. Okay? Express pi over 6 radians in degrees. So again, since we have radians and we want to end up with degrees, so we have pi over 6 times 180 degrees over pi radians. So we keep the radians in the denominator of the conversion unit, or the conversion term, I should say, which is, you know, here, 180 degrees over pi. Again, because we want the radians to cancel with the radians and end up with degrees. So the pi cancels with pi, and we end up with 180 over 6, which is 30 degrees. Okay. All right, and here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so express 45 degrees in radian measure. So here we start with degrees, right? But we want to end up with radians. So since we want to end up with radians, I'm going to keep the pi radians on top in the numerator of the conversion term, and then divide it by 180 degrees, right? Now 15 and 180. Oh no, not 15. I'm sorry. This is 45. 45 degrees. Where did I get 15 from? So 45 degrees times pi over 180 degrees. So divided by 45 is 1. Divided by 45 is 4. Right? And then the degrees obviously go away together, and we end up with, you know, the radian multiplication. So we end up with pi over 4 radians. Okay? Express 5 over 6 pi radians in degrees. So again, since we want the to convert to degrees, we're going to multiply by the conversion term with degrees on top. So times 180 degrees over pi radians equals pi cancels with pi. So we get 5/6 times 180 degrees, which is 150. So we could say divided by 6 is 1, divided by 6 is 30. So 5 times 30 is 150 degrees. Okay? Last exercise. Find the value of tangent of pi over 4 radians. So pi over 4 radians is equal to 45 degrees. And we just actually found this out, right? Well, we found the opposite of this in the first exercise. So we had 45 degrees, and then we converted to radians, we got pi over 4 radians. So pi over 4 radians is 45 degrees, right? So here, we can just rewrite pi over 4 radians as 45 degrees, and then we can just take the tangent of 45 degrees, which we do know, right? It's one of the common tangents with common values, and the value for tangent 45 degrees is 1. Okay? And this is it for this concept. See you in the next video.